Hello guys, welcome back to the channel. Today we're going to solve this Leetcode question which is sort colors and before diving into the question, I know it's been a long time since I have uploaded a video, but from now on, I'll keep on uploading the video till you guys get done with me and till you guys report my channel. So let's dive into the question right now. So the name of the question is sort colors, and in this question, we're basically given an array of objects colored red, white, or blue. We need to sort them in place so that the objects of the same color are adjacent with the colors in the order red, white, and blue. So, and we will use the integers 0, 1, and 2 to represent the color red, white, and blue respectively. And you must solve this question without using the library sort function. So we're basically given three objects. One is red, one is red, and then the second one is white, and the third one is blue. To make the question and the solution easier, the problem has been these objects has been represented with the integers 0, 1, and 2. In this, the 0 is nothing but red, and the 1 is nothing but white, and the 2 is nothing but blue. Now what we need to do is we need to sort them in place so that the objects of the same color are adjacent. So basically all the zeros means all the reds should be adjacent to each other. All the reds should be adjacent to each other. Since reds are represented by zeros, all the zeros should be adjacent to each other, and all the whites should be adjacent to each other. Since whites are represented by using ones, all the whites should be adjacent to each other, and all the two should be adjacent to each other because blue has been represented with by using 2, right? So we're basically, in simple words, what we need to do is we're given an array of integers. We just need to return the array in the sorted form. Means all the 0 should be on the first, all the 1 should be on the next, and all the 2 should be at the last. So the most basic approach that comes to that comes to everyone's mind is that I'll just do nums.sort. That's it, right? We'll get this answer. I- Suppose this is the array, and if we apply sort function here, and we'll get this answer, right? And if this is the array, and if we apply the same function, then we'll get this answer, right? But but they know that we are so intelligent that we're going to solve this question by using the inbuilt method. That's the reason they ask us to they ask not to use the library sort function. That doesn't mean that we should not we can use our own sort function, but we know that any sort function will take order of log n, the minimum of order of log n, and the maximum time complexity of order of n square, right? So but in an interview we can tell this approach, but he'll definitely gonna come up with this extra follow-up. Means, could you come up with an one pass algorithm using only constant extra space? One pass algorithm. You know, if we are sorting by using our sort function, it will definitely take two for loops, right? So this is not a one pass solution. So since we already knew this sorting, I'm not going through that. So I'm going to explain the one pass algorithm that came into my mind. I know that there are so many different ways that we can solve this question, but the thing that came into my mind is something like this. Let me come up with an example. So the approach that came to my mind is that suppose if we have this array, we need to convert this into this array, right? 0 0 1 1 and 2 comma 2, right? Now what I thought was, since we are at this point in this array, we only have three different numbers. One is 0, one is 1 and the other one is 2, right? We only have three different values. So what I did was, I'll take a pointer here, which will before that I know that I need to convert to this. If you observe this answer carefully, the left side is storing zeros and the right side is storing twos and the middle ones are nothing but ones, right? So what I'll do is, I'll take a pointer in the left which points to the zeros, and I'll take a pointer in the right which points to the twos. So this is the basic approach that came to my mind. Now what I'll do is, this is the zeros pointer. Initial I'll take this, and this is the twos pointer. Let me write with twos pointer, and this is the zeros pointer. So initially 1 2 0 1 2 0. What I'll do is, this is my I. My I basically starts from the beginning of the array. My zeros pointer will be here, and my twos pointer will be here. Now what I'll do is, I'll check if the I is pointing to 2. Suppose if the I is pointing to 2, then what I'll do is, I'll swap this one with the last pointer, because I know that when I encounter a 2, it must and should go to the last, right? So if I encounter a 2, I'll store it in the at the end, and if I encounter a 0, I'll store it at the beginning. You understood? You know what I mean, right? So basically what I'm doing is, if I encounter a 2, I'll basically move it to the end, and if I encounter a 0, I'll move it to the beginning. So in this way, the zeros will move to the beginning and the twos will move to the end, and eventually the ones will come into the middle. So basically we're doing this like this. So let's see how are we going to apply this approach with the help of an example. I'll take the same example. 1 2 0. What's 1 2 and 0. Now my ith pointer will be here, and my zeros pointer will be here, and my twos pointer will be here. Now what I'll do is, the ith value, the current value is 1. It is not 0, it is not 2, right? I'll only consider the cases whether when it's 0 or when it's 2. Since it's 1, I'm not going to do anything, because at the end the ones will eventually come to their correct places automatically. So when it's 1, I'm not going to do anything. I'll just move my pointer. I'll just take another color. So this is I. Now when I see 2, basically what I'll do is, I'll just swap it with the last element, not the last element, to the element onto which the 2's pointer is pointing. Since 2's pointer is pointing to the last element, I'll swap it with that element. Then it will become 1. The 0 will come here. There is a 0 here, 1 here, 2 here, and 2 here. My 2's pointer will be here, right? Since I already knew that after swapping 2 here, since I already knew that 2, the last element is 2, I'll move my 2's pointer to here, right? And my 0's pointer will be here only, and I will not move my pointer yet. This is because when I swap, I can either get a 0 or I can either get a 1, right? If I get a 0 and I move my pointer from here to here, if I move my pointer from here to here after getting a 0, then I'll be missing this 0, right? I'll be missing to swap this 0 with this one. So that is the reason when I swap my what they call the 2, I'm not going to move my pointer. I'm going to make the pointer stay at its place. So right now the current element is 0. So what I'll do is I'll swap it with the first element. Now my zeros pointer will move 0, these two will get swapped and it will be 0, I'm sorry, 1, 2 and 2. My 2's pointer is here and my zeros pointer is here. What I'll do is I'll just advance my zeros pointer and then swap it with the current pointer. That's it. Now when I swap it with the zeros pointer, what I'll do is I will just move my pointer right now. That is because this is because on the left I know that there will not be any 2 present, right? There can only be 1 or a 0, right? If I if I swap it with if I swap my 0 with either a 0 or a 1, I can move to the next pointer, right? I know it's a bit I know it's a bit confusing, but you'll understand. So again, right now I'm pointing to 0 and my zeros pointer is here. So I'll advance my zeros pointer and I'll swap these two, right? Now it will be like 0, 0, 1, 1, 2 and 2. Now I'll advance my pointer and then I'll see the element is 1. So I'm not going to do anything. I'll just move my pointer. And again my pointer my the element is 2 and the 2's pointer is also pointing to the same element. So I'll just swap these two, right? Then it will be the same array. And then I'll move my I to here and oh, I'll just stop when my ith pointer reaches the 2's because there's no point in moving in this direction, right? Because I already know that all the elements towards the right will always be 2, right? So that is the reason I'll stop here. So let's take another example. Let's say I took something like 2, 2, 2 and 2. Let's say this is the example and my zeros pointer is here and my 2's pointer is here and my I is here. I is here. Now what I'll do is I saw an 2, right? So I'll just swap it with the last element. So these two will get swapped and they will be the same, right? The array will be the same. It will be like 2, 2, 2, 2 again. So again my I will be here, right? So in this case it will be an infinite loop. So in order to overcome this case, we need to do is we need to move our 2's pointer in the beginning we need to move our 2's pointer till we don't find any 2. I'll explain you what I mean. 1 0 2 2 2. So if this is the case, this is the array, our 2's pointer is right here. What I'll do is I'll move my 2's pointer till here because I'm just representing that all the elements on the right are nothing but 2's. So from here, if I find a 2, I'll replace it with this element. So that is what I'm doing. In this case, how are we going to how are we going to solve face this or approach this situation is that we'll be having 2's pointer here and I'll be moving my 2's pointer till I don't find any 2 and eventually I'll go out of the boundaries which will be -1 and I already said that my I only goes till 2's pointer, right? Since 2's pointer is already -1, my I will not traverse through this array and I'll just return the same array. So that's it. So let's try to understand the solution now. So this is the solution. So what I'll do is I took a pointer. Pointer is nothing but the I that I have explained, and zeros pointer is nothing but this one, and the 2's pointer is nothing but the this one. Now as I said, I'll move my 2's pointer like if the 2's pointer is already pointing to 2, I'll just move it backwards. I'll just move it backwards until I won't find any twos pointer, or my twos pointer is within the bounds. Now what I'll do is, while my PTR is less than or equal to twos pointer, as I have already said, my I is nothing but here PTR. My while my PTR is less than or equal to twos pointer, what I'll do is, as I said, if my PTR is equal to 1, when my pointer is pointing to the 1, I'll just move my pointer to the next element. I'll not do anything. And if my pointer is pointing to 2, suppose if my pointer is pointing to 2, what I'll do is I'll just swap it with the last element, right? So that's what I'm going to do. I'm going to swap my current element with the 2's pointer. 2's pointer is pointing to the last element, right? So that is the reason I'll just swap those two, and I'll just decrease the 2's pointer. So I'll just swap these two, and I'll decrease the 2's pointer to its previous element. But I'm not going to advance this current pointer here. But when we are at zero's pointer, I'm sorry, zero's, I mean, when we are at zeroth element, what I'll do is I'll just swap it with the first element. In the code, I just took initially the zero's pointer at -1, and what I'm doing is, when I encounter a 0, I'll just advance the zero's pointer initially and then swap my element with the first element. I'm just advancing the zero's pointer and I'm swapping with it with the current pointer, and right now I'm moving my PDR. So I'll explain you why we need to move the PDR in this case. Because let's say we have this array, these are like base cases, right? Suppose my zero's pointer is right here and my pointer is here and my pointer is here. Now when I encounter a 0, what I'll do is I'll increase my zero's pointer to the first element. This is the zero's pointer, and I'll swap these two. Then it will be the same, right? 0 0 0 and 0. Now if I don't advance my pointer to the next element, my pointer will remain at the same position and the zero's pointer will remain at the same position, right? My pointer will never ever go till the end of the array, so we'll be stuck in an infinite loop, right? So that is the reason when I'm swapping the 0, I'm advancing the pointer. When I'm swapping with 2, I'm not advancing the pointer. This is because when I swap it with 2, I can get an element which can be a 0 or a 1 as well, or I can also get an element 2 as well, right? But when I'm swapping with a 0, I can only get a value 0 or 1. I don't know if it's making sense or not. Yeah, basically that's it. We don't even need to return the nums since they have given void. That's it. Even if I run the code, it will. I already ran the code. These are like from 2022. I have been solving this from 2022, and I got it right 2 hours before. So that's it, guys, for this video. Thank you for watching. Bye bye.